Okay, this video is on trapezoids, and a trapezoid is just a quadrilateral with exactly one pair of opposite sides parallel. Now, you may recall that the definition of a parallelogram is a quadrilateral with both pairs of opposite sides parallel. For a trapezoid, we just have a single pair of opposite sides that are parallel. Now, these parallel sides are called bases. So for this particular trapezoid, this side here and this side here would be the bases. The non-parallel sides are called the legs. So for this trapezoid, the legs would be this side and this side. Now we also have what are called base angles. The angles that are on one base, for example, these two angles here, these would be a pair of base angles. And we also have a pair of base angles up here. This angle and this angle. These are the base angles for this second base up here at the top. Now, there is a special type of trapezoid. If you have the legs of a trapezoid that are congruent, then the legs of a trapezoid are congruent. That forms what's called an isosceles trapezoid. So for this trapezoid here, it still has its single pair of opposite sides parallel. That's what makes it a trapezoid. But if the legs also happen to be congruent, then you have an isosceles trapezoid. And for an isosceles trapezoid, there are some other qualities, some other particular properties that are true only for an isosceles trapezoid. For example, we're going to call this isosceles trapezoid theorem number 1. For an isosceles trapezoid, the base angles are congruent. So in other words, for this isosceles trapezoid here, this angle here, angle D and angle C would be congruent, and also angle A and angle B would be congruent. Isosceles trapezoid theorem number 2 has to do with the diagonals of an isosceles trapezoid. For an isosceles trapezoid, the diagonals are congruent. So here we have these two particular properties of isosceles trapezoids. So we can use these properties to solve examples number 1 and 2. Examples number 1 and 2, it says, use isosceles trapezoid ABCD to answer these questions. So for example number 1, if the measure of angle ABC, so that's this angle here, is 116 degrees, what would be the measure of angle DAB? So that's this angle here. Well, since angle ABC and DAB are base angles of this isosceles trapezoid, and since for an isosceles trapezoid the base angles are congruent, angle DAB must also be 116 degrees. Now, the measure of angle ADC, that's this angle down here. Now, these two angles here, they're not a pair of base angles, but we do know that side AB and side CD are parallel. And since these two lines here are parallel, I could actually extend this line out a little bit and see that I have two parallel lines cut by a transversal, and these two angles here are same side interior angles. And I know that if two parallel lines are cut by transversal, same side interior angles are going to be supplementary. Therefore, this value must be 180 minus 116, which is 64 degrees. The measure of angle DCB, so that's this angle here. Now this angle here, ADC and DCB, this is a pair of base angles, and for an isosceles triangle, since base angles are congruent, those two angles must be congruent, so angle DCB is also 64 degrees. Now example number 2 has to do with the diagonals of an isosceles triangle. I'm going to leave example number 2 for you to work on your own. The median of a trapezoid. So the median of a trapezoid, you may remember that we have a special segment of a triangle that's referred to as a median. The median of a trapezoid is the segment that joins the midpoints of its legs. So here we have a trapezoid, A, B, C, D. And if I find the midpoint of its two legs, let's say here are my two parallel sides here, which means side AD and side BC are my legs. If I find the midpoint of this leg, and I find the midpoint of this leg, and if I connect those two midpoints, let's call this EF, then EF would be called the median of that trapezoid. Note both regular and isosceles trapezoids have medians. So this segment here, EF, is a median. It joins the midpoints of the two legs, which means that this segment and this segment are congruent. This segment and this segment are congruent. Now, there's a theorem called the trapezoid median theorem, which gives us a couple of other properties of the median of a trapezoid. The trapezoid median theorem says the median of a trapezoid is parallel to the bases and its measure is the mean, that is the average, of the two bases. All right, so the median of a trapezoid, it's parallel to the bases, so that means this median, I can go ahead and draw my parallel line symbol in here. So this median is parallel to the two bases, and its measure is the mean of the two bases. So let's take a look at what that might mean in these examples here. So example number 3. I'm told here for example number 3 that I have trapezoid ABCD and I have a median EF in that trapezoid. And I'm told for example number 3 that the length of AB is 6, the length of DC is 14, and I'm asked to find the length of EF. Well, according to my theorem on the median of a trapezoid, the length of my median is equal to the average of the length of the two bases. Well, I know the base AB and I know the base DC, so EF is equal to AB plus DC divided by 2. That's how I find the mean or the average of those two bases. So EF equals, let's see, AB is 6, DC is 14, divided by 2. That's 20 divided by 2. And so EF equals 10. Now, example number 4. If the length of AB is 2x minus 6 and the length of DC is 3x minus 3 and EF is 13, find the value for x. Well, once again, I have expressions for both of the bases and for the median, except now this time I'm going to have to set up an equation and solve for x. Well, I'm still going to use this same relationship that I used up here. That is, EF equals AB plus DC divided by 2. That is, the median of a trapezoid is just the average of the two bases. Well, now let me plug in all my different expressions that I have here. So let's see, EF is 13, AB is 2x minus 6, plus DC is 3x minus 3, divided by 2. And here I have an equation that I can solve. In fact, let me put 13 over 1, and I can see that my equation is going to be a proportion. So let's see, 13 over 1, let's see, let me combine my like terms, 5x minus 9 over 2. I can cross multiply here, and that will give me, let's see, 2 times 13 is 26, and 5x minus 9 times 1 is 5x minus 9. And let me see, I'll add 9 to both sides, and I get 5x is 35. Divide both sides by 5, and I get x equals 7. And that's what I was trying to find. Now, example number 5. It says the measure of angle ADC is 43. So let's see, ADC, that's this angle right here. So if the measure of this angle is 43 degrees, what's the measure of angle AEF, this angle right here? Well, I remember that since I have a trapezoid, I know that these two sides here, my bases are parallel, and my median is also parallel to each of the two bases. So I essentially have 3 parallel lines here. And if I'm trying to find this angle right here, if I extend out these lines, then I can see that I have 2 parallel lines cut by a transversal. These 2 angles here form corresponding angles, which means that this angle must be the same as this angle. So the measure of angle AEF is also 43 degrees. And now you have a couple more examples in your notes. I want you to do those on your own, and we'll take a look at those tomorrow in class.